Okay, let's unpack a specific kind of IT headache. I mean, we live in this world of 4K streams, wireless everything, but you go into the server room of, say, an airport, and
Oh,
you still see those old blue VGA ports everywhere, and then you have this problem. You need to get that signal to a screen that's, what, 2 football fields away?
and you can't. Not with a normal cable. Physics just says, no, you get signal loss, ghosting. I mean,
Yeah.
it's a mess. It's completely unusable.
Right. So today we're doing a deep dive into a piece of hardware that claims to fix this exact thing. It's the NTI ST-C5VA-R-600 VGA Receiver.
Hmm,
But I have to ask the big question first.
Go for it.
Why are we still using VGA at all? I mean, why not just upgrade everything to digital?
That's a fair question. It really is.
Mm.
But in these big industrial places, just upgrading can mean millions of dollars. You've got manufacturing controllers, HVAC systems, things that were installed 20 years ago.
And they work.
They work perfectly. They're rock solid, but they only speak VGA. So this NTI device is, it's a bridge. It's about getting that 90s signal to run over a 2020s building infrastructure.
So let's get into the how. The big claim is video and audio up to 600 feet. That's about 180 meters. But it's not using some big, expensive video cable, is it?
No, and that's the key. That's why people like it. It uses the cables that are probably already in your walls. Standard Cat5, Cat6, your basic network wiring.
So you don't have to rip open the drywall, but I'm still a little skeptical here. Analog video over, unshielded twisted pair, that usually kills the quality. You get all sorts of weird color issues.
That's where the engineering comes in. It actually supports a pretty high resolution, up to 1920 by 1440. But the sec you really need to look at is the video signal-to-noise ratio. It's rated at over 55 decibels.
And what does that mean for the person actually looking at the screen? Is the text readable?
It means the text is sharp. I mean, keeping a 55 dB ratio over 600 feet of copper, that's the real magic trick. Usually the signal would degrade and everything would get muddy and flicker. This receiver is actively cleaning it up.
So if I'm running like a flight arrivals board, the gate number won't be a blurry blob.
Precisely. And that gets to how it's designed. It's not just a simple adapter. The system has two parts: a local unit by the computer and a remote unit out at the screen.
And the local unit has a monitor output too, right? So you can see what's being sent.
Yes. And for any IT admin, that is a huge feature. You can have a monitor right there in the server room. You see exactly what's on the remote screen.
So you don't have to get on the radio and ask someone 600 feet away, hey, is the screen flickering? Is it black?
Exactly. You have local proof that the signal is good.
Let's talk about where this thing lives. It's not in a nice, clean office.
No, not at all. This is built for like a dusty utility closet. It's rated to work from 32 up to 100 degrees Fahrenheit. And this is critical. It has built-in surge protection.
Why is the surge protection so important?
Well, when you run a copper cable for 600 feet through a building, you've essentially just built a giant antenna.
Oh, right.
It'll pick up all sorts of electrical noise from lights, from machinery. Without good surge protection, a power spike doesn't just fry the $300 receiver. It could travel all the way back and fry the video card on your critical server.
So it's an insurance policy. Got it. Now, I did have to laugh when I saw the compatibility list. It has modern Windows and Linux, sure, but it also lists Solaris and Mac OS 9.
It sounds funny, I know, but it really gets to the whole point. There are still factories out there running robots on Solaris. This device doesn't care about the operating system. It just cares about the video signal. It lets those, quote, obsolete systems keep on working.
It's like a universal translator for old computers.
Yeah, in a way, it lets you keep the reliable old brain and just connect it to the building's modern nervous system.
So at the end of the day, we have a device that costs around $300, and its whole job is to keep old, reliable tech alive by letting it use modern wiring.
It's a very specific tool for a very specific problem. But if you're that engineer who needs to solve that problem, it's a lifesaver.
It really challenges our impulse to just upgrade everything. We assume wireless and 4K are always better, but
Well,
there's something to be said for a simple hardwired connection that just works.
it raises a really interesting question, I think. For our most critical infrastructure, is new always better? Or is there a kind of durability in these older, simpler analog standards that we've started to forget about?
Something to think about next time you see a perfectly clear departure screen at the train station. That's all for this deep dive. Thanks for listening.